All right, in homework 11.4, our big idea is connecting the zeros of a function with the factors and finding all the possible factors of a polynomial. So, I'm going to do number 2 here, I think with you. Write the equation of a polynomial in factored form that has zeros at x equals negative 2/3, x equals 1 with a multiplicity of 2, and x equals 0. All right, so, and it has in behavior. We'll read that in a second. So, let's see. If there's a 0 at x equals negative 2/3, then it means one of the factors must be x plus 2/3. Because when x is negative 2/3, negative 2/3 plus 2/3 is 0. X equals 1, well, there has to be a factor at negative x minus 1. And it's a multiplicity of 2, which means it occurs twice, so that's squared. And last, x equals 0 means there's a factor of x. We almost always put that right at the beginning. X times x plus 2/3. So here's our factor of 0. This is negative 2/3. We'll make this 0, and here is 1. Now, we don't leave this. We always have integer coefficients when we're writing our factors. And so you factor out, basically you multiply both of these by 3, and it still works. Because what you're really doing is you're factoring out 1/3. You're dividing everything by 1/3, which is multiplying everything by 3. So 3x plus 2 times x minus 1 squared. All right, and it has in behavior of as x goes to negative infinity, f of x goes to negative infinity. So as x goes to the left, y goes down. As x goes to the right, y goes down. And since both ends are facing down, it's a quartic. Here's our first factor, second factor, third factor, fourth factor. This is a quartic. It must have a negative in front. So we need to put a negative there. So we need to multiply this out. You can only multiply two things at once. It's kind of like if you're multiplying 5 times 7 squared times 2. There's like a best order to do this in. You can do 7 squared first. You can multiply the 5 times the 2. You can only multiply two things at once, but you can do pairs at once. So 5 times 2 is 10. 7 squared is 49. 10 times 49 is 490. That's the fastest way to multiply it out. And the same thing is true here. We've got x minus 1 being squared. Well, we have a shortcut for squaring a binomial. It's square the first one, multiply these two together and double it. So x times negative 1 is negative x, doubled is negative 2x, and square the last one. Negative 1 times negative 1 is positive 1. Here we can multiply the negative x times both of these. So we get negative, this is going to distribute, negative 3x squared minus 2x. And these are still multiplying 2 times each other, and so we need to multiply them out. So we're going to do that. I'm going to label it over here. F of x equals, all right, and when we multiply it out, we've got negative 3x squared times each of these is negative 3x to the fourth. X squared times x squared is x to the fourth. Negative 3x squared times negative 2x is plus 6x to the third minus 3x squared. And then the negative 2x is also going to distribute. So negative 2x times x squared is negative 2x cubed plus 4x squared minus 2x. And so f of x is equal to negative 3x to the fourth. We can combine our x to the thirds plus 4x to the thirds. We can combine our x squareds, so plus x squared, and nothing combines with the negative 2x. Cool. The last thing is we need to sketch a graph of the function. Well, what are some things we know about it? We know there are zeros at x equals 0, at x equals negative 2/3, at x equals 1, and that one has a multiplicity of 2. And we also know the in behavior goes down in both directions. So it's going to look something like this. Now, we know that because this has a multiplicity of 2, the way that looks on a graph is that it makes a little mini quadratic there, kind of bounces off of it. It looks something like this. Where it doesn't actually go through it, it makes like a quadratic that has a vertex there. So it looks something like this. And, you know, I don't know exactly what's going on in the middle here because, you know, I don't have those values. But I do know that those zeros are correct. I know the y-intercept is 0. So that matches up. This is about all I can do for this. All right. On the back, I'll do one more. What are all the possible zeros of the function f of x equals 12x cubed minus 8x squared minus 49x minus 15? And the zeros have to do with what the factors of this could be, right? Well, the constants need to multiply to make negative 15. So it could be like 15 and 1. Or maybe it's 3 and 5 and 1, right? It could be like 3, negative 5, 1. There are all these different possibilities that could multiply to make 15. And the x's need to multiply to make 12x cubed. So it could be like 2x, 3x, or maybe it's 2x times 6x times x, right? There's a whole bunch of different things, and based on these, we'll get a bunch of different possible zeros. The zeros will be what makes each of these equal to 0. So it's the factors of this plus or minus the factors of this. Everything will look like this. Px plus q. I guess we usually do qx plus p, I believe. It doesn't really matter what we're labeling them. Where q has to be a multiple of the x cubed term, and p is the multiples of the constant. So these are like the two key parts here, because when you multiply it all out, you know, all the x's multiply together to make 12x cubed, and all the constants multiply together to make negative 15. And so each of our factors is this, and when you set it equal to 0 and solve, you subtract p. And so x is negative p over q. And so it's just all the possible factors of this divided by the possible factors of this, and it could be positive or negative in both cases. So I'm going to list out the factors of negative 15. 1, 3, 5, 15. I'm going to list out the possible factors of 12. 1, 2, 3, 4, 6, 12. And it's all the factors of this one divided by all the factors of this one. So I'm just going to start with 1. So it's plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. These are the possible zeros if this goes with 1. Then we could also have all of these divided by 2. So plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, plus or minus 15/2. We can also divide them all by 3. So yeah, I didn't leave myself enough room here. Plus or minus 1/3. We don't have to do 3/3 because 3/3 is 1 and we already did 1. Plus or minus 4/3. 6/3 is 2. We already put that one. 12/3 is 4. We already put that one. So we don't have to put them again. Next, we can divide them all by 4. Plus or minus 1/4. Plus or minus 3/4. Plus or minus 5/4. Plus or minus 15/4. None of those can be simplified, so we don't have those already. Now we can do 6. Plus or minus 1/6. We don't have to do 3/6 because that's 1/2. We already did 1/2. 5/6. And 12/6 we don't need to do because, 15/6 we don't need to do because 15/6 is, we could divide them both by 3. That's 5/3, which we already put somewhere. I messed up here, guys. When I said 1/3 and 4/3, it should have been 1/3 and 5/3. 5 was getting divided by 3. I apologize. So there's my 5/3 that I already did. And last, we can divide by 12. So plus or minus 1/12. We don't need to do 3/12 because 3/12 is 1/4. We already got that one. 5/12. And 15/12 we already have is 5/4. We already did that one. Okay. Could x plus 3 be a factor? Well, I mean, maybe, but we can actually check this one. If x plus 3 is a factor, then that means x equals negative 3 would be a 0. And so the question is x equals negative 3 a 0? So what I'm going to do is there's a cool way to do this, and I'm just going to say in my calculator negative 3. I'm going to store that in for x, And so now whenever I put x, like x plus 5, it'll do negative 3 plus 5, which will be 2. If I do x squared, it'll be negative 3 times negative 3, which is 9. And so I can just evaluate it. 12 times x cubed, so this is doing 12 times x to the third, minus 8x squared, minus 49x, minus 15, and this is plugging in negative 3 in for x and seeing does it make it equal to 0. And it does not make it equal to 0, it makes it equal to negative 264. So this is false. So x equals negative 3 is a 0 is false, so x plus 3 is not a factor. Even though it was a possible factor, it was one we needed to check. You do need to find one actual factor of the polynomial. So you need to check these and see which one makes it equal to 0. I strongly recommend using a calculator, or, here is a thing you can do. If you graph this, you can find where it crosses 0. If you find where it crosses 0 by using a graph, that's a completely appropriate way to do it, and I'm fine with you using a calculator on this one. All right, I'm going to let you do the rest of this on your own. Good luck.